Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the absolute extrema of each function on the given interval. So we are given these three functions. So let's start with the function on the left side. So in order to find the absolute extrema, the first step is to find the derivative of the given function and then set it equal to 0 and then solve for the values of the variable, the independent variable. We do that because when the derivative is equal to 0, that means the slope of the tangent is equal to 0, and that means the tangent is horizontal. So we get the points at which the function forms peaks and valleys in the graph of the function. So the first step is to find the derivative. So we start with prime of f at x. Now this function is a polynomial function, so we'll have to use the power rule for each term to find the derivative. So in the first term, so 3 is a coefficient, so 3 stays as it is, and as per the power rule, so the derivative will be 4x cubed. And in the second term, so 4 is the coefficient, so it stays as it is, and the derivative of x cubed is 3x squared. In the third term, 36 is the coefficient, so it stays as it is, and the derivative of x squared is 2x. And 20 is a constant, so its derivative is equal to 0. Now we can simplify this term. So prime of f at x equals, so 3 times 4 is 12, x cubed, minus 4 times 3 is 12, x squared, and then 36 times 2 is equal to 72, so negative 72x. Now we have to input the value of the prime of f at x as 0 and then solve for x. So we get 0 equals, so 12x cubed minus 12x squared minus 72x. Now we can simplify this equation by doing common factoring. So we can factor out 12x. So 0 equals 12x and then parentheses, so x squared minus x minus 6. Now we can factor the expression in the parentheses. So this is a simple trinomial, so we can use the sum and product rule. So we have to find two numbers whose sum is -1 and product is -6. So the numbers are -3 and 2, because -3 plus 2 is equal to -1, which is the coefficient of the x term, and -3 times 2 is -6. So our factored form will be 0 equals 12x times x minus 3 times x plus 2. Now we get three cases to solve this equation. So the first case is 12x equals 0, and from that we get x equals 0. So the second case is, so x minus 3 equals 0, and from that we get x equals 3. And the third case is x plus 2 equals 0, and from that we get x equals -2. Now in this case, all these x values lie in this given interval, which is from -3 to 4. So that means we have to find the function value at 5 x values. So the x values at which we have to find the function value are So we start with the lower bound of the interval, which is x equals -3, then x equals -2, then x equals 0, then x equals 3, and finally x equals 4. So these are the 5 x values at which we have to find the function value. So let's start with -3. So we can start our calculation here. So f at -3 will be equal to, so 3, so we sub in x as -3 and -3 exponent 4, then -4, then -3 exponent 3, minus 36, and -3 exponent 2 plus 20. Now we can simplify these terms. So 3 times and then -3 exponent 4 is equal to 243. And then -4 times -3 cube is equal to 108. So it will be positive 108. And then -36 times -3 square will be equal to -324. And then plus 20. So now we can combine all the terms. F at -3, so we got 243 plus 108 minus 324 plus 20 equals 47. Now we can find the function value at -2. So f at -2. Now we sub in x as -2 in the given function. So 3 times -2 exponent 4 minus 4 times -2 exponent 3 minus 36 times -2 exponent 2 plus 20. Now we can simplify it. So 3 times -2 exponent 4 is equal to 48. And then minus 4 times -2 exponent 3 is equal to positive 32. And then -36 times -2 square is equal to -144. And then plus 20. So now we can combine these terms. So f at -2. So now we do 48 plus 32 minus 144 plus 20, which is equal to -44. Now we can find the function value at x equals 0. So f at 0, so we sub in x as 0 in the given function. So it will be 3 times 0 exponent 4 minus 4 times 0 exponent 3 minus 36 times 0 exponent 2 plus 20. So the first three terms will just become equal to 0. So f at 0 is equal to 20. Now we can find the function value at x equals 3. So we can do it here. So f at 3. So we get 3 and then times 3 exponent 4 minus 4 times 3 exponent 3 minus 36 times 3 exponent 2 plus 20. So now we have to simplify this expression. So f at 3. So 3 times 3 exponent 4 is equal to 243. Then minus 4 times 3 exponent 3 is equal to 108. and then minus 36 times 3 square is equal to negative 324, and then plus 20. Now we can combine these terms. So 3 equals, so 243 minus 108 minus 324 plus 20. So I got negative 169. Now we have to find f at 4. So sub in excess 4 in the given function. So 3 times 4 exponent 4 minus 4 times 4 exponent 3 minus 36 times 4 square plus 20. So we get f at 4 equals, so 3 times 4 exponent 4 is equal to 768 minus 4 times 4 exponent 3 is equal to 256, and then minus, so 36 times 4 exponent 2 is equal to 576 plus 20. So now we can combine these terms. So we do 768 minus 256 minus 576 plus 20 equals negative 44. So now we have to compare these 5 function values. So the first one, second one, right, the third one, the fourth one, and the fifth one. So based on the values we got, so we can conclude that the minimum value exists at x equals negative x equals 3, and the minimum value is negative 169. So we can write here, so minimum value is equal to negative 169 at x equals 3. Now we can write the maximum value. So the maximum value is 47, and it occurred at x equals negative 3. So now we can also write that here, or I can write it here on the side. So the maximum value is equal to 47 at x equals negative 3. So this is how we can summarize our answer for the first problem. So now we can analyze the second function. So now the second function is a rational function. So the first step here is to find the derivative of this function, to find the x values at which the tangent is horizontal. So for this we'll have to use the quotient rule to find the derivative. So prime of f at x equals, so we start with the derivative of the numerator, which is 4 times the denominator x squared plus 1 minus the numerator expression times the derivative of the denominator, which is 2x plus 0 over the square of the denominator. Now we can simplify the numerator by distributing the 4 into the parentheses. So we get prime of f at x equals, So in the numerator we get 4x squared plus 4, and in the second part, so 2x plus 0 is just 2x, so 4x times 2x is negative, so we get 8x squared over x squared plus 1 squared. Now we can set the derivative equal to 0 because we have to find the x values at which the tangent is horizontal. And in the numerator, we can combine the x squared terms, so we get negative 4x squared, because 4x squared minus 8x squared is negative 4x squared plus 4 over x squared plus 1. Now we have to solve for x, so we can cross multiply the denominator. So 0 times the denominator will be equal to 0. So 0 equals negative 4x squared plus 4. Now we have to solve for x. So first we'll add 4x squared to both sides. So 4x squared on the right side will cancel each other out. So we get 4x squared equals 4. And now we can divide both sides by 4. So the 4's on the left side will cancel each other out. So we get x squared equals 1. And now we can apply square root to both sides. So the square root and the square on the left side will cancel each other out. So we get x equals plus minus 1. Now we got two x values, plus 1 and minus 1, and both of them lie in this given interval, which is from negative 2 to 4. That means for this function, we have to find the values of this function at x equals negative 2, which is the lower bound for the interval, and then x equals negative 1, and then x equals 1, and then x equals 4. So let's start with x equals negative 2. So we'll sub in x as negative 2 in the given function. So f at negative 2 will be equal to 4 times negative 2 over negative 2 squared plus 1. So we get f at negative 2 equals negative 8 over, so negative 2 squared is 4 and plus 1 is 5. So this is the value of f at negative 2. Now we'll do the analysis for x equals negative 1. So f at negative 1 is equal to 4 times negative 1 over negative 1 squared plus 1. So this can be simplified too. So 4 times negative 1 is negative 4 over negative 1 square is 1. 1 plus 1 is 2. So we get f at negative 1 equals negative 2. Now we can do the analysis for x equals 1. So f at 1 equals, so 4 times 1 over 1 square plus 1. So f at 1 is equal to, so 4 times 1 is 4. So 4 over, so 1 square is 1 and 1 plus 1 is 2. So f at 1 is equal to 2. Now we can do the analysis for x at x equals 4. So f at 4 equals, so 4 times 4 over 4 squared plus 1. So we get f at 4 equals, so 4 times 4 is 16, and over 4 squared is 16, and 16 plus 1 is 17. Now we have to compare these 4 function values to find the absolute maximum and absolute minimum. So in this case, So the absolute maximum value is equal to 2 and it occurs at x equals 1. So maximum is equal to 2 at x equals 1. And now the minimum value is equal to negative 2 at x equals negative 1. So this should be the final answer for the second function. Now we can analyze the third function. Now in the third function is the same as the second function. The only difference is the interval. So the given interval for the third function is 2, 4. Now the x values at which the tangent is horizontal for this function is x equals plus minus 1, which we found in the second problem. Now these values plus and minus 1 do not lie in this given interval 2 to 4. So for this function we just have to do the analysis at f at 2 at x equals 2 and x equals 4. So for f at 2, so we'll do 4 times 2 over 2 squared plus 1, which is equal to 8 over 4 plus 1, which is equal to 8 over 5. Now we already calculated in the second problem that f at 4 is equal to 16 over 7. So that means for the third problem, so the absolute minimum or the minimum value is 16 over 17. So we can write so minimum value is equal to 16 over 17 at x equals 4. And the maximum value is equal to 8 over 5 at x equals 2. So this should be the final answer for this third function. So these are the steps you have to keep in mind to solve a problem like this one. So as you can see, if we get multiple points for analysis, then the calculations become a bit tricky. So you have to be careful with the calculations so that you don't make any mistakes along the way. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.